Oh, big audience. Oh, I'll just go click, 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 I think. This is the trouble with the graveyard shift, isn't it? Okay, all right, okay. So I'll do this UDMI, an open protocol for smart buildings. UDMI stands for Universal Device Management Interface. And I'm going to talk about where it comes from and where it fits in this hierarchy that was really devised by Google, but has been adopted by some parts of the industry now. And we kind of see this, we see this within Delta Controls as an open way of connecting buildings to cloud with a standard machine readable format that makes sense. So there's some elements to it, and it'll be expanded upon as I go through the presentation. So first of all, a building operating system. Lots of companies talk about building operating systems for their cloud connectivity, and they sell an independent data layer and various ways of putting some box on a network in a building or a set of boxes to collect data, normalize it, send it up to the cloud. The problem with this is generically is everybody does it differently. So the whole world of IoT and cloud connectivity becomes the Wild West. Everybody does their own thing. The fundamental problem they're trying to solve is to take these silos. Traditionally, building services are siloed. The lighting guy doesn't talk to the security guy. The energy guy doesn't talk to anybody. The BMS guy is a poor bloke who gets the blame for everything. And they're all in silos. They don't talk to each other. And when somebody needs to come along to get the data out, they need to know how to talk to each one of these silos individually. So the concept of the building operating system is to turn the vertical system into a horizontal system, have all the devices at a layer at the bottom, and then the data feeds up, and the data gets normalized at the lowest level. So that's the dream, that's the goal. Various people have come up with different ways of doing it, but they're trying to achieve the same thing. So that's the building operating system, which is the overarching architecture of what they're trying to achieve. Why would you want to do this? The why in this one is really because it's all about the data. People want the data from the building to be in a standard that they can understand, or a format they can understand, and they want to fill a, come on clicker, they want to fill a data lake, which is a cloud database full of data that they can make sense of and they can understand. The goal being having a beautiful, clear data structure that everybody can access and understand. The problem is it doesn't always, the reality is usually quite different from that, and you end up with, instead of a nice clean data lake, you have a muddy swamp, and you can't understand what the data is. It makes no sense to anybody because everybody has their own spin on everything. So in order to combat that, the guys at Google and Arup and some consultants and some people from OT and IT and BMS world got together and came up with this concept of having these three ways of normalizing the data. Device qualification, which is about the security of the devices that are connected to a building's network, to a corporate network, and that's really about securing the devices that are connected to the network in terms of the security of the business. Because you need to be sure that whatever you plug into the network in the building is not going to compromise the cybersecurity of that building. So there are a set of tests that are defined that test a device to make sure it complies with the right standards and it is secure. UDMI is the syntax. So this is the protocol for how to communicate. So this is the open protocol that people can understand. And the ontologies is the semantics. So that's really just what do we name things. The ontologies are the naming convention. So I'll talk about these in a little bit more detail, not too much detail. So I'll go through device qualification first. This is really a set of tests that are provided by Google. They have a piece of software that you can download. It's all available on GitHub. Developed by Google, and it runs on a Linux platform. And the idea is you put this on a machine, on a Linux machine, you plug in your device, whatever that device is, to that machine, test run, and it will test all of these parameters, all of these device tests to see if it complies or not. And it's really, we talk about cybersecurity on pen testing. Pen testing is penetration testing, well known in the IT world, and it came out of this this book that was written by these three people who work for Google. That's where it started about 10 years ago now. These are the tests, or they aren't the detail of the tests, but these are the the names of the test groups that they do. So they test the connection to the network, they test DHCP, how it gets an IP address, and various groups of tests, and the number of tests. So you can see there are 12 different tests for connection and so on down the chart. I'm not going to read the charts out. So these are tests that they do to make sure the device is compliant. So that means the device is compliant. The network security guys, who are like the police of any building network, will say, okay, if you comply with all of this and you pass all these tests, then we will allow that device to be connected to our network. There are 2 levels of device qualification. There's this testing to get a compliant device, and then there's another set of tests if you're going to connect the building to the cloud. And that really means that you then need to have a load of IoT tests for transmitting the data to the IoT. These numbers are the same. If I go back a slide, you can see it's 12, 7, 2, 5. 12, 7, 2, 5, same number of tests, but you can see here, the reason it's all shrunk is because there's quite a lot of IoT tests that they do. And there are at the moment there's an enablement coming with smart buildings where devices are connected to the building and the building is effectively smart ready. If those of you who are old enough might remember when HD came out in TVs, and a lot of TVs were HD ready. So it's a similar kind of concept. So we're smart ready. So we've got a device that's capable of doing it, even though you're not using it yet. And if you actually do want to have smart, then this is the extra set of tests that are required. So that's really qualification. There's a slide here. I don't know whether these presentation will be published afterwards, but there's all links to where you can get all the information from. This is all open source. There's no fees, you don't have to buy any of this. Next stage would be UDMI, Universal Device Management Interface. So this is the language that is defined to push the data into the cloud data lake to make things work. And it's really the difference between this is a management interface rather than just a method of taking a piece of data from a building, putting it into the cloud. So that means various things. One of which means that not only does the device send data into the cloud, it can also have data pushed back down into it to change settings, to adjust set points. They allow the concept of over-the-air upgrades. So if you think about how your phones work, when your phone gets a new cybersecurity patch or a new version of the operating system, it just happens. Something pops up on your phone. It says a software update available. Do you want to install it? And you go, yes, please. So that's the same concepts with this. So that the device gets an instruction. Oh, you can update yourself. There's a new version. You can download that and install it. Because the alternative of that is, if you think about a big building, there might be 1,000 of these in the building. So if you don't have some automatic system of doing it, then it means somebody has got to go to the building with a USB stick or something and update the firmware in 1,000 controllers, which is not scalable. So UDMI allows for that, and that's a really important piece of what UDMI does. That's why it's device management, not just a protocol. It's also broker agnostic. It uses MQTT. MQTT, for those that don't know, I describe it as Twitter for computers. With Twitter, you tweet and follow. So I follow your feed. When you tweet something, I get a message. MQTT is exactly the same. I think it's the same platform, actually, but they call it publish and subscribe. I subscribe to your topic. When you publish to that topic, I get a notification. Same technology. And there are various MQTT brokers, IoT companies that provide this infrastructure. UDMI is agnostic. It doesn't care what the broker is. Each broker has different ways of connecting to it, but UDMI, in principle, once you've got the connection established, it doesn't matter because it's just MQTT. So the way it works is the authentication is the login. In the early days of computers, you log in with your username and your password. The problem with username and passwords is they're very easy to hack. These days they use a certificate. TechnoGeek X509 is an IETF standard for logging into a system. It's like a passport, and it's a much more secure way of doing it, much more secure than usernames and passwords. So that's how the device presents itself to the cloud. It says, "Here I am. Here's my passport. Can I connect, please?" And as long as everything's okay, the connection is established. Everything allows. Once the connection is established, the cloud then sends a data packet down to the controller to say, "Okay, this is what I need you to do." So the fundamental difference there is the cloud is saying, these are the points I need you to publish to the cloud, rather than somebody having to go to the device. Remember, there might be 1,000 of these in a building, and the device then has to be configured so it knows what it needs to publish. And then when the guys say, oh, actually, we missed some data points off there, we need to change that, somebody has to go back to the devices to change it. So if you get the cloud to tell the device what it needs it to do, then you only need to change it in the cloud. And you can be on the beach doing that. You don't have to go to the building. So that's a key thing. And the other parameters about over-the-air updates and endpoint redirection all come through the configuration packet. So that's where that message to the device, this is what I need you to do, comes from. Once the device is configured, it then sends status back. The status goes periodically, so the cloud knows the device is there, it knows what version it is, various parameters that are defined within UDMI, and subsequently the telemetry, which is the important bit. This is the readings from the values, the statuses, the set points, all come out of the controller, published periodically to the cloud into the data lake. That's pretty much UDMI. We provide a UDMI module for our devices. List of resources there. Again, this is all open source. There's no fees for any of this. You just put it in, you buy the controller, you load it in the controller. And other manufacturers also support this protocol. Whether they're free or not, I can't comment. The last piece is the ontology that's used. Google, on their buildings, they've got their own ontology. People have probably heard of Haystack. They've probably heard of Brick. There are other ontologies. What Google did is they looked at Haystack and, okay, don't quite like that. Some bits I don't like in there. Then they looked at Brick. Came out of University of Berkeley in California, and they looked at Brick, and there was a bit more. They quite liked Brick, but it didn't quite do everything they wanted to do. So they, as Google being Google, wrote their own and then open sourced it. So some people use DBO, some people use Haystack, some people use Brick, some people make up their own. It really doesn't matter. The important thing is, because it's just the name you give things so you can understand what they are when they're in the data lake. So the important thing is you pick one and use it. Doesn't matter which one you pick. So just a couple of slides about what DBO is. It classifies things as entities rather than pieces of equipment. And you have entity types, and they define everything. So it will define an air handling unit or a lamp fitting or a chiller, whatever that piece of equipment is as an entity type. And you have different types of air handling unit, different types of chillers, but they're defined within DBO. And then an entity has properties. Properties being a temperature reading, a valve position. There's a property of an entity and a relationship. So when the valve opens, the temperature should change. Things like that. So they within the ontology, it describes what is expected from that piece of equipment. The point with that is it makes the ultimate goal of this, which is machine learning to do the fault detection and diagnostics, easier, because the ontology describes what happens and provides a set of tools to allow things to be queried. Typically there, fan coil unit, that's what a fan coil unit, one type of fan coil unit would be. It's got a sensor, it's got to give it a room temperature, it's got a monitor for, is the fan running, switch the fan on, switch the fan on, control, open the heating valve, open the cooling valve. So that's how they would describe it. And then there would be another fan coil with maybe more or different types. That's what typically a payload would look like in MQTT. So this data structure is called JSON, JSON, JavaScript Object Node, more techno babble. The key point there is what it's doing is, this is the ontology. So this is a name that I've given something, fan coil unit number 901, maximum fan speed, and the value that's coming out, so it's currently 100%. So this is just what the data looks like, and this is the ultimate goal of what it is. This is the ontology. This whole thing is the UDMI data payload. So this thing gets into the data lake, and some other machine learned program can understand it and make use of it. And that's it really. And the whole thing is, as I say, JSON. Again, there's a slide there with links to, if you want to do it. It's open source again. Anybody can use it. I think that's probably me. Thank you very much.